y'all, happy Monday. Welcome to our math class. It is the first day of our fourth quarter. Wow. Y'all, I can't believe we are already in the last quarter of school. And speaking of quarters, I am so excited. We're starting a new unit today. It is all about fractions. And of course, quarters are just fractions. So that's perfect. I hope you had an awesome spring break. I hope it was relaxing and restful, or you did something exciting. Or it was just boring. If anything was bad in it, let me know. I'd love to hear. Also, if you want to share good things or just normal things, I'd love to hear them too. Feel free to pop into our help session tomorrow or on Thursday this week, or shoot me a message on Schoology. We can find a time outside of school hours to talk if you'd like. I'm always here for you, whether it's for good things or for bad things, happy things, sad things, whatever they are. I'm here for you. I would love to listen. So one of the things we're doing in our live classes today, which is going to be a little awkward right now, just because we can't have that back and forth of a conversation, but don't worry, I'm going to try this anyway. So I've been asking everybody to share one thing about what you did last week. And it can be something good, it can be something bad, or it can be just something normal, something that happened over the course of the last 9 days or so. And to start, I'll share an example of all three. Something good, something bad, and then something just normal. So my good thing, the thing I was really excited about happening on the Monday of spring break, I got my second dose of the COVID vaccine. So I've now had both COVID vaccine doses, and I am so thrilled. My thing that was bad, Bailey, you all know Bailey, my dog. She had some stomach issues over spring break, and that made it very difficult for us. I felt bad for her because she was feeling bad. She's doing much better now, but she had a rough couple of days. And then something that was just normal. I watched some more of The Amazing Race. It's one of my TV shows I've been watching. Excuse me. It's actually really the only TV show I've been watching. There are 32 seasons. I have watched seasons 1 through 29. 30 and 31 are currently not available for free anywhere. So I have jumped ahead to 32, and I've started watching season 32. So that was pretty normal, pretty boring on my spring break. But I would love it if you want to share one or more of those things, something good, something not so good, or something pretty average. If you want to send me a Schoology message or a text or call me or pop into help session tomorrow, I'd love to hear what's going on in your life. But as we move on from that, we are going to dive into our next unit. I already let you know it was about fractions. But specifically, it's going to be about adding and subtracting fractions. And I'm stoked. I'm so excited. You have probably already learned about adding fractions with like denominator. That's when the number on the bottom of the fraction is the same on this fraction and this fraction. That means it's a like denominator. The denominator on the bottom is the same. And you've probably seen putting together and taking apart whole numbers or wholes into fractions. But this year in 5th grade, we get to deal with fractions that don't have the same bottom number, the same denominator. So I'm really excited about that. We are going to start with a couple of days of review. If something we talk about today doesn't look familiar at all, let me know. I know COVID was a thing last year and you missed a chunk of school. Actually, this whole time last year you weren't in school. So if there's something that makes no sense whatsoever, it's okay. Let me know. You don't have to let me know in a public setting. You can send me a message or pop into our help session. If something doesn't look familiar at all that we may have talked about before, let me know and we can work through it. We can get you caught up and we can make sure you are an all-star rock star in math. All right, so without further ado, I'm going to kick us off to our first problem of the day today. Here we go. Awesome. Let's take a look at this problem right here. And I just wrote down the basics, but there are 15 kilograms of rice that we want to separate equally into 4 containers. How many kilograms are in each container? And you can see down here that I wrote the word kilogram. That's not obviously part of our problem or a step to solve it, but it is really important that we understand the parts of the problem. Now, if you're like me, you probably had some rice over spring break in at least one meal. I made some fun bowls with some rice and some cucumbers and some carrots. You may have had some rice too. If you didn't have any rice over spring break, chances are you probably know what rice is, which is awesome. You know, 4 containers, just 4 vessels to hold the rice. They could be bowls, they could be storage containers. But kilograms, we've probably seen that word before, and we might not know what it actually is. And I'm going to angle that down just a smidge there so you can see my hands a little bit better. So I want to break that down and just talk about what a kilogram is, because I know what a kilogram is, but when I was trying to think, okay, what is a kilogram actually? And I was trying to think of that this morning, I couldn't really tell you. So I do know that the word kilogram is a root word of gram and a prefix that means part of a word that comes at the beginning of kilo. Now, kilo is an awesome mathematical word. Kilo means 1,000. You might have seen that kilo in a kilometer, kilometer, in distance. Kilo or kila is really kilo, but when you have kilometer like this, is kilometer. Kilogram means 1,000 or 1,000 meters, and a meter is about a yard, and a yard is 3 feet. So if you hold one arm out to the side and go from your shoulder to the tip of your finger, that's probably about 3 feet, maybe, or out to your elbow over there, because I know you all are probably a lot shorter than I am. That's a meter. So then 1,000 of those would be a kilometer, kilometer. Okay, but then let's talk about grams. If meters are talking about distance, grams are a unit of measure of weight, how heavy something is. Now, I was talking with some of my math friends, specifically Miss Vandagetti today, and I said, Miss Vandagetti, do you know how big a gram is? Like, if you told me, if we were talking about the ones that we use, the measures of weight that we use here in the U.S., we have pounds, we have ounces, we have tons. And if you said, Mr. Spencer, how big is a ton? Or how big is a pound? I could picture a pound of cheese in my head. I could picture a ton as a big pallet of rocks, but I could not tell you how big a gram is. So I did some research. And a gram is right there. A paperclip is about a gram. So, a kilogram would be 1,000 of these paper clips. That's a lot of paper clips. Okay, well, back to our problem. Now that we understand what a kilogram is, we can kind of picture that problem a little bit better in our head. I know it wasn't the most important thing for us to do right there was break apart kilogram, but I do think it was important for us to think about. Now, I want us to read this problem together. And it's going to be awkward because we're all at our houses. Well, I'm here in an empty classroom. You're at your house, or you're at the beach, or you're at the park, wherever you are watching this video. But we're going to try and read this problem together. 15 kilograms of rice separated into 4 containers. How many kilograms in each container? What do you see when you hear this story? What can you draw? Are you going to have to add, subtract, multiply, or divide? Okay, well, I know that I'm going to have to take 15 kilograms of rice and divide it into 4 containers because of that word separate. That word separate tells me, hey, when I am separating this, I am splitting it up. When I split something up, I need to divide. So I want you to pause this here, solve this problem, and we'll come back together and check our work. Awesome. Y'all, When you do 15 divided by 4, you do not get a whole number. You get either a fraction or a decimal. You get either 3 and 3/4 or something like 3 and 75 hundredths, which you could also write as a decimal as 3 and 75 hundredths. Now I got to slide it up so we can see all of those, but there are some possible answers. Now there are different ways to write the same answer. If you have questions about how you got to the solution you got to, or how your solution may have been different than mine, let's talk it out. Come see me tomorrow on a Tuesday or any Thursday, and we can talk this through. If you're not available during school hours, let me know, and we can meet sometime outside of school hours. But I just want to put different answers there that we could check our work. And of course, we want to label our answers kilograms, and we label kilograms kg. Awesome. All right. So, now I'm going to turn to the next page. And you either need a blank page or you need a separate piece of paper. Either one works. Now, if we were all here in person and we did not have COVID, I would hand you a strip of paper instead of a whole sheet of paper. But alas, we are not all here. We still have the COVID. So I'm going to walk you through what to do. We have our piece of paper. If you're on a separate piece of paper, that is awesome. Fold it in half like that. If you are doing this in your notebook, just draw a line down the middle. So if you have folded your paper in half, it looks like this. If you have drawn a line down the middle of your paper, it looks like this. Either way, that line is going to be in the same spot. And how many spots? Oh, before we do that, please go ahead and draw a number line across like this. So draw a line across horizontally. That means from left to right. So it intersects your line, or it intersects your crease. That means it goes opposite direction of your crease. And that line is the best line I have drawn yet today. All right. Now I want us to see how many parts we have here. Well, it looks like we have one part here and one part here. Now if we didn't have this crease, we know, and I'm going to put this in a different color just so we can recognize this. If we were all the way over here and it was just uncreased, that would be one hole, right? If we had 0 to 1. And so this would over here be 0. But now we have folded our piece of paper in half, or we have cut it in half with our line. We didn't actually use scissors. Nope. We drew our line, or we folded it. So now there are 2 total pieces. So instead of this being one whole, we now have 2 parts here. And we're going to put everything in a fraction where our denominator is 2. Now our denominator is going to be 2 because there are 2 parts. One part here and 2 parts here. Oh my goodness. Okay, so we said right here we had 1 part. So at this point, we're going to put a 1 as our numerator because we have 1 part. And our denominator is 2 because there are 2 parts in one whole. So over here, if this was 1 part, so we put a 1 up here, there are now 2 parts, so we're going to put a 2 up here. And we remember that 2 halves is equal to 1 whole. These are our fancy math word of the moment is equivalent. And that means equal fraction. I'll slide that up a bit so we can a little bit higher now. There we go. Now my question for you. What number would go above this 2? What number goes above this 2? Absolutely. It's going to be a 0 that goes above this 2. What made you say it was going to be a 0? Was it because you said, well, hey, if there was a 0 here, that means there's nothing over to the left, there's no paper, so 0 is equal to 0 halves? Or did you notice, hey, we took this 1 and multiplied by 2 to get 2, so we'll take this 0 and multiply it by 2 and get 0. But any way you look at it, we have our 0 on our number line, and 0 is equal to 0 halves, 0 thirds, 0 70-seconds, whatever it is. And then, oh, maybe you noticed this pattern. We went 2, 1, 0 on our numerators. Interesting. Okay, well, I want you to take your piece of paper. If you have your piece of paper that is torn out, if you have your notebook, we'll get there in just a minute. If you have a piece of paper that is separate, fold it back in half, and then fold it in half again. And you should end up with a little tiny strip of paper like this. And then unfold it, and look, oh, now you have more sections. Now I'm going to cut mine vertically, so if you're doing it in your notebook, you can do this as well. Cut each of these sections in half. And then I'm going to switch to red. Now we had 2 sections up here. Now we have how many down below? We have 1, 2, 3, 4. So if there's 4 sections, that means our denominator in each section is going to be 4. Because remember, our denominator in a fraction is how many parts are in a whole. Okay. So should we start from left to right, or should we go from right to left? Oh, you want to skip around? Okay. Let's start on the right. We know that this is one whole strip, one whole model, one whole piece of paper. And we know one whole is equal to how many fourths? Well, absolutely, it's going to be 4 fourths. Because there are 4 parts, and there are 4 parts in a whole. Oh. Did you notice that we went from 2 to 4 by multiplying by 2? 2 times 2 is 4. And if we do something, because we want everything to be equivalent, and equivalent means equal, whatever we do to the bottom number of our fraction, or the denominator of our fraction, we also have to do to the top number, because everything must stay equal and balanced. So if we multiply the denominator by 2, we also need to multiply the numerator by 2. So 2 times 2 is 4. Let's jump to this middle one. We want to create an equivalent fraction. So we're going to follow the same process. We're going to figure out what we multiply our denominator by to get our new denominator. 2 times 2 is 4. So then we have to take our numerator and also multiply it by 2. 1 times 2 is absolutely 2. Do you think that one would work down here? Could we follow the same step? 2 times 2 is 4. So then we would take our numerator. 0 times 2 is 0. Does that sound right? 0 fourths? Sounds good to me, because we're over here where there is nothing to the left besides this handle. So what number would go here? What number could go here? Well, let's look at the pattern. We're going 0 to 4. Between 0 and 2 is 1. But guess what? It's also 1 because we have now one section. So I have 0, 1, 2, 3, 4. And we also have 3 sections here. 1 section, 2 sections, 3 sections. So on here, we have some equivalent fractions. There are some equivalent fractions. Here are some equivalent fractions. And here are some equivalent fractions. And remember that 1/2 and 2/4 are equal, 0 halves, 0, and 0 fourths are equal, and 2 halves is equal to 4/4 is equal to 1. Awesome. Well, now I want to look at equivalent fractions a different way. So I'm going to go to my next page of my notebook. If you were on a separate piece of paper, dive back into your notebook, and we are going to draw a chart. I think I might sneeze first, though. Excuse me. Whew. So I want to draw a box. And in my box, there are going to be 3 parts. So since there are 3 parts in my box, we already know that we are working with thirds. I want to shade it in one box here. So the fraction we have shaded in one part. Remember, in a fraction, our part goes on top, and our whole goes on the bottom. So we have 1 on top because there's 1 part shaded in, and there are 3 parts in our whole, so our fraction represented right there is 1/3. A really terrible 3, but it is a 3 nonetheless. You see that 1 part shaded in, 3 total parts, we have 1/3 shaded in. But wait, what if I cut each of these thirds into 2? Did I change the amount that was shaded in? Nope. The amount that was shaded in still didn't change. But the number of pieces did change. Now there are 2 pieces shaded in. Did the number of total pieces change? Now there are just 3 pieces. There are 6 pieces in the whole, so our denominator is 6. Are these 2 fractions 1/3 and 2/6 equivalent? Absolutely they are. We have the same amount shaded in on each model, but we've changed the number of total pieces, which has changed the number of parts shaded in. Now we're going to get really tough, so I hope you're ready. I know you're ready, so that's great. Now we're going to cut each of these apart again. Again, I have not changed the amount of total area. The box size did not change. And I also did not color in any more or any less in yellow. But now I want to know how many parts are shaded. I have 1, 2, 3, 4 parts are shaded. And how many total parts are there altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 parts shaded in all. So each of the 3 fractions that we just wrote, 1/3, 2/6, and 4/12, all 3 of these are equal or equivalent. Awesome. All right, well, y'all, that is just about it for us today. As we wrap up today, I hope there is my notebook that I need. Your problem to go today is to make 3 equivalent fractions to the number 2/3. So just like we did, where we said 1/3 was equal to 2/6 was equal to 4/12, I need you to find 3 equivalent fractions to 2/3. Once you've done that, you are good to go. If you have any questions, as always, let me know. We'll be doing some practicing with equivalent fractions tomorrow on Tuesday. And feel free to stop into our help session at any point tomorrow. I hope to see you there. Y'all have an amazing day. Welcome to the 4th quarter one more time. Y'all, I am so excited. I can't believe we're in the last quarter of 5th grade. Just so close, but we're going to keep working hard. We've got a lot to get through this quarter, a lot to learn, but you are going to do so great. Have an amazing day. I love y'all. I'll see you soon. Goodbye.